Hello everybody, welcome to Mathethics original channel. Thank you for watching our videos. Please don't forget to like, share, or subscribe. In today's video, we will use the following table to identify whether each one represents a linear function or exponential function or quadratic function. And to do that is to identify if there is a common difference for linear, or a common ratio for exponential, or a second difference for quadratic. So how do we do that? Let's begin. For the first one right here, let's first identify if there is a common difference. Now, the way you do that, now notice that this table, which is the first term of that table, begin with 6. All right, this table begin with the 6th term. Now let's see if between the 6th and the 7th term, or what do you add to the 6th term to get the 7th term. Okay, so the 6th term is 11 and the 7th term is 13. So 11 plus 2 is 13. So we know to get from the 6th term to the 7th term, we add 2. And 13 plus 2 is 15. So to get to the 7th term to the 8th term, we add 2. And 15 plus 2 is 17. So to get from the 8th term to the 9th term, we add 2. 17 plus 2 is 19. So to get from the 9th term to the 10th term, we also add 2. Notice that we add 2, always add 2 from the previous term to get to the next term. So that's what we call a common difference. So in this case, a common difference is 2. Right down here. So the common difference is 2. So therefore, this one right here is a linear. So that's linear. Okay. Now, let's try the second one. Let's try this one now. Now, this table begins with the first term. Okay, the first term is 64. The second term is 128. The third term is 256. The fourth term is 512. And the fifth term is 1024. So, do we have a common difference here? So, we know we can add 64 to 64 to get 128. But however, if we add 64 to 128, we will not get to 56. All right, 128 plus 64 is not 128, is not to 56. So therefore, we're gonna try to multiply. We also know by multiply 64 by 2, we will get 128. So if we multiply 64 by 2, we will get 128. So if we go ahead and multiply 64 by 2, we will get, all right, we will get 128. Okay, we multiply this by 2, we get 128. And if we multiply 128 by 2, we will get 256. So to get from the first term to the second term, we multiply by 2. To get from the second term to the third term, we multiply by 2. And to get from the third term to the fourth term, we also multiply by 2. To 56 times 2 is 512. And to go from the fourth term to the fifth term, we also multiply by 2, because 512 times 2 is 1024. So in this case, we have to multiply the previous term by 2 in order to get the next term. So that's what we call a common ratio. Okay, we call that a common ratio. So in this case, our common ratio is also 2, because we multiply by 2. So because we had to multiply by 2, in this case it is exponential function. Okay, so that's exponential. Now, on the third one here, we have the first term is 36, the second term is 49, the third term is 64, the fourth term is 81, and the fifth term is 100. So we know if we divide 49 by 36, if we divide 49 by 36, we will get 1.36. And if you keep multiplying by that same thing, it's not gonna hold. Okay, so we do not have a common ratio here. But however, if we add, let's see if we have a common difference. If we add 49 minus 36 is 13. So if we add 13 on the first term, we got the second term by adding 13. And then if we add 64 minus 49 is 15. 81 minus 64 is 17. And 100 minus 81 is 19. So notice, we do not have a common difference here. We already know it's not exponential because there is not a common ratio. Okay, if you there is not a number, like let's say if you do 49 divided by 36, you're gonna get a number. But if you do 64 divided by 49, you're gonna get a different number. So therefore, it's not there is no common ratio here, so it's not exponential. And also the fact that you keep adding different number from the previous term to get the next term, so there is not a common difference. But what we're gonna do is to check to see if we have a second difference. All right. So by doing the same thing. So what do we add from 13 to get 15? Okay, so we're gonna identify what do we add from 13 to get 15. So we add 2, right? So we know 13 plus 2 is 15, and 15 plus 2 is 17, and 17 plus 2 is 19. So now that's what we call the second difference. All right, so that is the first difference. So the first difference work for linear function. Okay, the first difference work for linear function, but the second difference work for the quadratic function. So if there is a second difference, then we can conclude that it is a quadratic function. Okay, so the second difference here, second difference is 2. So therefore it is a quadratic function. Okay, so let's try the next one. Over here, the table starts with -2. So that's the first one in the table is -2. So let's see if there is a common difference here. So -17, if we add 5 to -17, we get 12, right? So we're gonna add 5 here. And -12 plus 5 is -7, so 5 again. -7 plus 5 is -2, so we add 5 here again. And -2 plus 5 is 3, so we add 5 here again. So notice we add 5 to the previous term in order to get the next term. All right, so we keep adding 5 each time. We keep adding 5, we keep adding 5, and we keep adding 5. So each term, so that's when we have a common difference here, and our common difference is 5. So common difference in this case is 5. And because we have a common difference, we can conclude that this one is linear. Okay, so this is linear. Now let's check this one right here. So here, on this one right here, the first term is 9, the second term is 6, the third term is 5, the fourth term is 6, and the fifth term is 9. So let's see if we have a common difference or a common ratio or a second difference. So if we subtract 3 from 9, you get 6. But if you subtract 3 from 6, you don't get 5. Okay, so 9 minus 3 is 6, but 6 minus 3 is not 5. So therefore, there is not a common difference. Now, let's see if there is a common ratio. So 6 divided by 9 is 2/3. Alright, so that's 2/3. So, but 5 divided by 6 is not 2/3. Alright, 5 divided by 6 is not 2/3. So there is not also a common ratio. So let's see if we have a second difference. So we know 9 minus 3 is 6. Okay, that's from here to here. And 6 minus 1, you subtract 1 here, give you 5. 5 plus 1, you add 1 here, give you 6. And 6 plus 3, give you 9. Okay, so you got -3, -1, plus 1 plus 3. Now let's see if we have a second difference on that one. So -3 to -1, that's -3 minus 2. Okay, -3 minus 2 give you -1. Sorry, -3 plus 2 give you -1. Okay, -1 plus 2 give you +1. All right, so far so good. And 1 plus 2 give you 3. So notice that we have a second difference. So our second difference is 2. Okay, the second difference here is 2. So therefore, since we have a second difference, this table represents a quadratic function. Quadratic function. All right. So let's do the last one now. So on the last one, this one right here, the first term is 80, the second term is 40, the third term is 20, the fourth term is 10, and the fifth term is 5. So let's see if we have a common difference here first. So we know 80 minus 40 is 40. So from the first term to the second term, we subtract 40. But if you do 40 minus 40, you not get 20. So it's not linear. Right? So since the number change is not linear. So let's see if it is exponential. So we know from the first term to get to the second term. So if I do 80 divided by 40, so if I do 80 divided by 2, so I get 40. Okay, so or if I do 40 multiplied by 1/2, I get 80. So therefore, over here, we multiply the first term by 1/2. Okay, we multiply this by 1/2 to get the second term. And also, if I do 40 divided by 2, I get 20. Okay, so which means I multiply this again by 1/2. Okay, and if I do 20 divided by 2, I get 10, which means I multiply by 1/2. So 1/2 is the same. Multiply by 1/2 is the same thing as saying divided by 2. Okay, so and from the fourth term to the fifth term, so 10 divided by 2 is 5. So which means I multiplied by 1/2. So with that being said, since in order to get the next term, I multiply the previous term by 1/2. So therefore we have a common ratio, and that common ratio is 1/2. Common ratio is 1/2. And since we have a common ratio, then the table represents an exponential function. Okay, so in summary, we just did identify on each table whether each table represents a linear function or exponential function or quadratic function. And remember, a linear function have a common difference, or what we call the first difference. All right, so which means you add or subtract that same number constant from the previous term to get the next term. All right, and exponential function has a common ratio. So the common ratio means like you multiply or divide a same number from the previous term to get to the next term. So that's the common ratio. And a quadratic have a second difference. So after you do the first difference, if it doesn't work, then you do the second difference. So if the second difference gives you a constant, then you can say it is a quadratic function. That's all we have for this video. So thank you for taking your time to watch the whole video. So if you have any question, suggestion, comment, let us know in the comment box. Don't forget to like, share, and subscribe. And I will see you next time in the next video.